Alright, so our first set of example problems, we're asked to find the missing side of each triangle and round our answers to the nearest tenth if necessary. So let's start with number 1 because, hey, that's a good place. First, if we're going to use the Pythagorean theorem to find a missing side, we have to confirm that this is a right triangle. We see our box right there that tells us that this is a 90-degree angle. So we know that this is in fact a right triangle, and now we just need to label the sides. Now remember, the most important thing is that C is going to be the hypotenuse. That's the one directly across from our right angle. So here I'm going to put underneath this, we're going to say what A, B, and C are. So C is going to be X, the one directly across from there. Now A and B, it really doesn't matter which leg I choose. I'm going to call A 8 and B 6. So now I've got A, B, and C, and the Pythagorean theorem tells me that A squared plus B squared equals C squared. And all I'm going to do is substitute those values in. So just as we did with the quadratic formula, anytime I substitute something in, I'm going to put it in parentheses. A was 8, B was 6, and C was X. We didn't know that one. So let's go ahead and fill these out. So we know that 8 squared is going to be 64. 6 squared is going to be 36. So this is 8 times 8, 6 times 6. And x to the second power is just x squared. Well, now I can go ahead and combine these. 64 plus 36 is 100. And that's still going to be equal to x squared. I want to find out what x is by itself, so in order to undo x squared, I have to take the square root of that. If I take the square root of that, I have to take the square root of that as well. And what I'll find is that the square root of 100 is 10, and the square root of x squared is x. Now the really keen-eyed among you might go, wait a second there, Mr. Kelly. When we took this earlier, we had to say this was plus or minus 10, and that is absolutely true. But now think about what x is. It's the length of a side of a triangle. The length of a side of a triangle is not going to be negative 10, so positive 10 is the only choice that makes sense here. So that right there is our answer. X is equal to 10. We can do the same thing over here. I find my right angle, so this is a right triangle, and now I'm going to identify A, B, and C. C is the one that's most important. It's the hypotenuse directly across from the right angle, so it will be 9.9. B, well, I can use either one of these. I'm going to say that B is 7.2 and A is X, just like that. Now it's time to pull out our Pythagorean theorem. A squared plus B squared equals C squared, and just as before, we substitute in the values we know. A is X, B is 7.2, and C is 9.9. Notice now that it's A is the side that I'm missing. It's the side that I don't know the length of, so I'm going to be finding this. That means we'll have a few more steps than before, but that's all right. X squared is just exactly what it says on the tin, x squared. And now I'm going to pull out the calculator for the rest of this. So 7.2 squared is 51.84. 9.9 squared will be 98.01. And it just occurred to me that you couldn't see what I was doing in my calculator, but there's all it was. So now that we've gotten to this point, we need to find x squared. So in order to do that, I need to get the x squared by itself. So I'm going to subtract 51.84 from both sides. And when I do that, on this side of the equation, I'm left with just x squared. And on this side, I'll have 98.01. Hey, how about I actually show you what I'm doing on my calculator this time? Minus 51.84. So that's going to be 46.17. Notice that I'm not rounding until my very final step. I want to keep as many numbers in there as possible. Now, in order to find x by itself, I have to take the square root. And so x is going to be the square root of 46.17, which is 6. Oh my goodness, a whole bunch of stuff. But remember, I was supposed to round to the nearest tenth if necessary. Tenth is one place past the decimal point. So I'm going to round off here, and I see that the number next to it is larger than 5, so this is going to round up to be 6.8. Alright, now we have a different example, and note the difference in the direction. Last time we were supposed to round to the nearest tenth. Here instead, we're asked to leave our answers in simplest radical form. But it turns out that how we work the problem is really not any different. We still need to identify A, B, and C. C is going to be the side length directly across from the right angle. So C is going to be 8. And then A and B could be either one of those, doesn't really matter. I'll call A x and B 6. And now I'm just going to use the Pythagorean theorem. A squared plus B squared equals C squared. Substitute in what I know. So that's x squared plus 6 squared equals 8 squared. I can simplify that to be x squared plus 36 equals 64. And now to get the x squared by itself, I'm going to subtract 36 from both sides, and I'll find that x squared is equal to 64 minus 36, which is 28. And so now what I'll need to do is, since I want my answers in simplest radical form, is that when I take the square root of this, I need to simplify the square root of 28, which is exactly what we did in our last objective. So if I take the square root of 28, I need to get the prime factorization of that. So I can come over here and do a quick factor tree. 28 is going to be 4 times 7. 4 is 2 times 2. And those are my prime factors. So I take 2 times 2 times 7. I have a group of 2 right there, and I'm going to pull that out to the front, leaving me with that. So that's my simplified form. So I can come down here and say that x is equal to 2 root 7. And this has some advantages. When you round, you actually lose some accuracy. Whereas if I do this and I leave it in simplest radical form, this gives me that full decimal without rounding at all. So I haven't lost any accuracy by leaving it like this. So when you see something asking you to leave your answers in simplest radical form, this is what we're looking for.